Did FAST telescope find alien radio signals? Hidden in the middle of the Chinese mountains, there's one of the biggest astronomical observatories that we ever built. It's called FAST, and it is a radio telescope 500 meters in diameter. Generally speaking, the resolution of a telescope goes with the inverse of its diameter. The bigger it is, the better the resolution. And since in the radio regime the resolution is worse, radio telescopes have to be huge in order to resolve faraway objects. This telescope is able to study the radiation coming from the most distant galaxies, the primordial ones. Some of them lie something like 13 billion light-years away from us. The telescope can provide information about the supermassive black holes that these galaxies host in the center. These should be the first supermassive black holes born in the universe. But perhaps the most interesting thing about this telescope is that being a radio telescope, it can detect radio signals from potential alien civilizations. Maybe somewhere out there is some alien civilization trying to get in touch with us by means of radio signals. Who knows? So, in a nutshell, this telescope could be one of the first steps towards interplanetary communication. Now, everything is set and astronomers are only waiting for the first data release. They will analyze and process it, and the results will be available for everyone. But some info leaked out. They seem to have found something really strange. And maybe there is a chance that they actually detected a signal from an extraterrestrial civilization. Global Times, which Twitter describes as China's state-affiliated media, was one source that published the story, which was based on this now-deleted report. It says China's FAST radio telescope has found several possible technical traces and suspected signals of extraterrestrial civilizations. But how do we recognize an alien message? And why did they delete the tweet? Every time we deal with the search for extraterrestrial intelligence, SETI, one of the biggest problems is noise. In fact, the more our telescopes are sensitive, the more the chances of finding something interesting. But we also detect a lot of noise, which is basically a lot of useless data that scientists always strive to get rid of. Take a look at this image. It shows a typical example of a signal, along with its associated noise. In fact, every instrument has its own background noise, something associated with the instrument itself. The so-called signal-to-noise ratio is an important quantity to be defined. The ratio is typically expressed as a single numeric value in decibels. The ratio can be 0, a positive number, or a negative number. A signal-to-noise ratio over 0 dB indicates that the signal level is greater than the noise level. The higher the ratio, the better the signal quality. For example, a Wi-Fi signal with a signal-to-noise ratio of 40 dB will deliver better network services than a signal with a signal-to-noise ratio of 20 dB. If a Wi-Fi signal-to-noise ratio is too low, network performance can be impacted because it becomes more difficult for devices to distinguish the desired signal from the noise. This can result in dropped packets and data retransmissions, leading to lower throughput and higher latency. On the other hand, noise could be everything that is considered non-important for your research. For instance, if your research is about supernovae, it might happen that surveying the sky, you might find some asteroids crossing your telescope. Therefore, you will have some signals that are noisy to you, in the sense that they are considered unimportant, even though they might be useful to other astronomers working in the field of asteroids. It only matters what you are looking for. Shortly speaking, you decide what's noise and what is not. When we were at the beginning of our research with telescopes, everything was a bit easier in a sense, because the first telescopes weren't that powerful, and they could only detect very strong signals, and we were basically only interested in bright sources that were quite distinguishable from the background noise signal, for example, of the telescope itself or the sky signal. But now we are making a different science, and we are looking for an ever-increasing number of low-emission sources. Therefore, we really want to get rid of the noise as much as possible. Guys, trust me, it is an enormous problem. The radio telescopes we have today are so powerful that they would be able to detect radio signals from planets far away from us, up to something like 10 light-years away from us. If there was a control tower on a plane 10 light-years from us, And if this control tower was sending out radio signals, we would be able to detect them. This is how powerful telescopes like FAST are. The problem is that this signal would be so weak that we wouldn't be able to distinguish it from the noise of our sample. In this case, one thing that might help in the future could be artificial intelligence. AI could help us distinguish between the signal that we are looking for and the noise. We sure would not be able to do the job. Hey, if you're still here watching the video, it means you are really enjoying it. We constantly strive to make videos that excite a curious person like you, so be sure to subscribe now and press the bell notification. But don't despair. The more a telescope is being used, the more astronomers are aware of its limitations and contributions to the noise. This is good news because FAST is a brand new telescope, and it is new indeed. We are pretty confident astronomers will have time to better understand how to get more reliable and decipherable data. Also, the Chinese scientific community never had such instrumentation before, and therefore they are new to this kind of job. Maybe it will take some time for them to get rid of the noise, but in the end they could find reliable signals. This, of course, doesn't mean that the upcoming data release doesn't contain alien signals at all, but probably it is too soon to tweet "we found one." So what happened with the tweet? Well, as Zhang Tongji, chief scientist of China ET Civilization Research Group, said, the possibility that the suspicious signal is some kind of radio interference is also very high, and it needs to be further confirmed or ruled out. This may be a long process. Zhang is also reported to have said that the team spotted 2 sets of intriguing signals in 2020, while sifting through FAST data gathered in 2019. Another signal was apparently picked up this year in data gathered on exoplanet targets. However, Zhang reportedly also underscored the possibility that the signals are products of radio interference. What does this mean? It means that every day on Earth, there is an indefinitely large amount of emissions that could make their way into the telescope. Maybe the telescope detected one of such signals by mistake. Basically, radio pollution rather than alien civilization could be the reason for this detected signal. The technical term we use is RFI, radio frequency interference. RFI can come from cell phones, TV transmitters, radar, satellites, as well as electronics and computers near the observatory that produce weak radio transmissions. This is important to remark. For instance, the SETI project, dedicated to the search for extraterrestrial life, had already found something like this in the past. Basically, all of the signals detected by SETI researchers so far are actually made by our own civilization. We are the alien civilization. And the thing is, with radio pollution increasing over time, it's getting really hard to do SETI observations from the surface of the Earth. Someone suggested that we might as well consider going on the far side of the moon to do SETI work. So if you are interested in engineering, why don't you come up with a clever and cheap idea to build a nice radio telescope on the moon? There, your beautiful telescope will be shielded from all of our planet's radio pollution. This isn't the first time we mistake an alien signal for a terrestrial one. For example, in April of 2019, the Breakthrough Listen Initiative, BLI, performed observations of our nearest stellar neighbor, Proxima Centauri, with the Parkes Murayang telescope in Australia. We were originally searching for stellar flares. Learning more about these flares can help us understand the habitability of planets around small M dwarf-like stars like Proxen. 2 years later, the same data was reanalyzed in the context of SETI, looking for technological radioactivity from Proxen. Shane Smith, a student working with Breakthrough Listen over the summer of 2020, was the first one to notice that the routine analysis had picked up something unusual. For once, no one in the group had an immediate answer to what could have caused the signal in that plot. Here's the plot. As you can see, there's a line that crosses the plot from left to right. That was a strange signal. First of all, it was a narrowband signal. Signals this narrow have no known astrophysical source and are typical of artificial transmitters. But perhaps the most interesting thing was that the signal appeared to be absent in the off-course observations, as would be expected for a signal coming from a single point in the sky. It was almost as if some aliens had built an artificial transmitter and were pointing it towards us, sending signals in a specific band. What the researcher did was very careful research to find a match between all the possible radio signals generated here on Earth. And what they found was that BLC1, as the signal was called, was an intermodulation product of some Earth-based transmitter. Intermodulation production is a characteristic of a particular kind of transmitter inefficiency or malfunction. So it wasn't aliens. It was our malfunctioning transmitters. As you can understand, science is always exciting, but it is made up of little steps that sometimes might seem boring. Imagine astronomers working at the Fast Radio Telescope. This telescope detects something like 38 billion signals per second. Imagine the huge quantity of data FAST collected during the course of 1 year. All of it is going to be analyzed and processed by supercomputers, and I would say super astronomers. We just have to wait until we have more reliable data. And who knows, maybe we will finally find some evidence for extraterrestrial civilizations. Wouldn't it be exciting if we did? That's all for this video. What do you think about it? Let us know in the comments below, and be sure to watch our other video about alien life through the YouTube end screens, playlists, and cards.